So we can use these skills of solving rational equations to rearrange formulas, meaning if we have this formula with multiple variables, we can solve for one of the other variables, dealing with rational expressions. So first thing we want to do is find the least common denominator, multiply both sides by that least common denominator, and then it's all about isolating that variable that we want to solve for. So in this first example, we want to solve for y. So I want to rearrange this equation such that I have y equals, and then whatever it's equal to. So my least common denominator is just the y minus 5. So what I would do is multiply both sides by y minus 5. So on the left-hand side of the equation, I'm going to multiply this out. So I'm going to have an x times y minus 5 times x. On the right-hand side of the equation, that y minus 5 cancels out, and we would just have 5 left over. And again, I'm focusing on solving for y, so I want to get that term alone on one side of the equation, so I'm going to add 5x to both sides. So we'll have x times y equals 5 plus 5x. And then my last step, in order to get y completely alone, I need to divide both sides by x. So we would have y equals 5 plus 5x over x. And you can leave the answer just like that. If you wanted to, you could separate the fraction up as 5 over x plus 5x over x. And then we would see x's cancel out. So really this would be 5 over x plus 5. That's also correct solution here. All right, with this one, solving for y, we can see y coming up in 2 spots here. But what I want to start with is getting rid of that denominator. So my least common denominator would just be that 3y plus 4. I would multiply both sides of the equation by that 3y plus 4. So on the left-hand side over here, x is going to distribute in. So this will be a 3xy plus 4x equals 7y minus 5. Now, what I would want to do here is move the terms with y all to one side of the equation. Doesn't matter which side. So let's go ahead and subtract 7y from both sides. So then what I would have over here is 3xy minus 7y plus 4x equals negative 5. So there I can see y, I can see y again, but then I have this term without y, so I want to move that away. So I'm going to subtract 4x from both sides. Then I have 3xy minus 7y equals negative, doesn't really matter, negative 4x minus 5. All right, so then what I'm going to do is I see y showing up in both spots, but it's hard because they're unlike terms, so I can't combine them. What I can do is factor out y. So I can factor out y, and then that would leave me with 3x minus 7 in parentheses equals negative 4x over minus 5. And now I have this multiplication here of y times and all that stuff in the parentheses. So what we can do is just divide it away. 3x minus 7, 3x minus 7. So y is equal to, because on the left-hand side there, that 3x minus 7 will completely cancel out. And we'll have a negative 4x minus 5 over 3x minus 7. Again, having that negative in front of x there, you could also rearrange this to factor out the negative. In this case, it would be from the numerator. So you'd see a positive 4x plus 5, and then the denominator is not touched. All right, let's try that with these formulas here. So this is our formula. Actually, this relates time, distance, and rate. So time is equal to a distance over rate. And we want to rearrange this solving for r. So what we could do is taking this, our least common denominator is technically r, so we would multiply both sides of the equation by r. And what that would do is then we'd have rate times time is equal to distance. Those rate values will cancel out. And then we want to solve for r, so I would divide t away. So we rearrange this so that it's rate equals distance divided by time. This is a way to help us rearrange formulas, so if we actually want to solve for a different piece, then we can have it all set up. All right, here we're solving for a plus b. Now, we could do cross multiplication, like we talked about before, or you could see a least common denominator. So again, with that addition, that a plus b is kind of bundled together. So our least common denominator is r times a plus b. So what that would mean is I would have 1 over r times a plus b, and that equals this a over a plus b times r times a plus b. So on the left-hand side, the r's would cancel out, so we would just have 1 times a plus b. And on the right-hand side, the a plus b expressions would cancel out, so we would just have a times r. And we're solving for b, so all I would need to do is subtract away a. So then we would have b equals a times r minus a. So we've rearranged our formula to solve for b.